Have you ever wondered what makes your electronic devices work? Welcome to the fascinating world of transistors, the tiny building blocks that power up the technology around us. These silent heroes are at the heart of most electronic devices, regulating the flow of electricity and making everything from your smartphone to your microwave function. Today, we're going to focus on two types of transistors that are the backbone of the electronics industry: the MOSFET, or metal oxide semiconductor field effect transistor, and the BJT, also known as the bipolar junction transistor. Each of these transistors has its unique structure, operation, and applications. While they both serve as active components for amplification and switching, they operate on different principles and have distinct characteristics. So fasten your seatbelts and prepare your curiosity, because we're about to embark on an electrifying journey. So buckle up as we dive into the fascinating world of MOSFETs and BJTs. First off, let's uncover the mystery of MOSFETs. Diving into the world of electronics, we encounter the MOSFET, an acronym for metal oxide semiconductor field effect transistor. Now that's quite a mouthful, isn't it? But don't worry, we'll break it down. Imagine a MOSFET as a three-layer sandwich. The bread slices are the semiconductor substrate, and smack in the middle, we have a metal gate. But wait, there's more. The metal gate is insulated from the bread by a thin layer of oxide, usually silicon dioxide. This is the basic structure of a MOSFET. Now, how does this sandwich work? Well, the flow of current between the source and drain terminals, or our bread slices, is controlled by the voltage applied to the gate terminal, our sandwich filling. When a voltage is applied to the gate, it creates an electric field that modulates the conductivity of the channel between the source and drain terminals. There are two main types of MOSFETs. First, we have the NMOS or N-channel MOS. The channel here is composed of electrons, and the device is turned on by applying a positive voltage to the gate. Then we have the PMOS or P-channel MOS. In this case, the channel is composed of holes, and the device is turned on by applying a negative voltage to the gate. MOSFETs aren't just fascinating to talk about, they're also extremely useful. They play a vital role in digital circuits, serving as switches and amplifiers in integrated circuits, or ICs. Thanks to their fast switching speeds and low on-state resistance, they're also used in power electronics for high-frequency switching. In essence, MOSFETs are like the invisible workforce powering our digital world, from our smartphones and laptops to satellites and even electric cars. Their ability to control current flow with precision makes them indispensable in modern electronics. So that's the MOSFET for you, a key player in the electronics industry. Next, we move on to the realm of bipolar junction transistors, or BJTs. Diving into the structure of a BJT, it's composed of three semiconductor regions: the emitter, the base, and the collector. Imagine it as a sandwich, with the base being the meat tucked between the emitter and collector bread slices. The BJT comes in two main flavors, NPN and PNP. Now, how does a BJT operate? It's all about controlling the flow of current between the collector and emitter terminals, and this is managed by the current flowing into the base terminal. Picture it as a river dam. The base emitter current is like a small stream that controls the opening and closing of the dam gates, regulating the much larger collector-emitter current. Let's explore the two types of BJTs. First up, the NPN. In this type, the majority charge carriers are electrons. When you apply a small current to the base, it's like flipping a switch. The current flows from the collector to the emitter, lighting up your electronic circuit. On the flip side, we have the PNP. Here, the majority charge carriers are holes. The current flows from the emitter to the collector when a small current is applied to the base. It's the same principle as the NPN, just the direction of flow is reversed. So, where do you find BJTs flexing their electronic muscles? They're used in both analog and digital circuits. In analog circuits, they often take the stage as amplifiers. They take a weak signal and boost it up, like a vocalist's voice in a concert. In digital circuits, they can be used as switches, although MOSFETs are typically the preferred choice due to their higher speed and lower power consumption in most cases. And there you have it, the BJT, a versatile component in both analog and digital electronics. Now that you're familiar with both MOSFETs and BJTs, let's summarize their key points. Starting with MOSFETs, or metal oxide semiconductor field effect transistors, they consist of a metal gate insulated from the semiconductor substrate by a thin layer of oxide. When we talk about their operation, it's all about the flow of current between the source and drain terminals, which is controlled by the voltage applied to the gate terminal. They come in two main types, enhancement mode and depletion mode. Then we have the specific types, NMOS and PMOS. NMOS has an electron-based channel and is turned on by applying a positive voltage to the gate. On the other hand, PMOS has a hole-based channel and is turned on by applying a negative voltage to the gate. MOSFETs are the stars in the world of digital circuits. They're used as switches and amplifiers in integrated circuits, and they shine in power electronics due to their fast switching speeds and low on-state resistance. Switching gears to BJTs, or bipolar junction transistors, they're made up of three semiconductor regions: the emitter, the base, and the collector. The flow of current between the collector and emitter terminals is controlled by the current flowing into the base terminal. They come in two main types, NPN and PNP. In NPN BJTs, the majority charge carriers are electrons, and current flows from the collector to the emitter when a small current is applied to the base. In PNP BJTs, the majority charge carriers are holes, and current flows from the emitter to the collector when a small current is applied to the base. BJTs have a strong presence in both analog and digital circuits. They're often used as amplifiers in analog circuits, and they can be used as switches in digital circuits, although MOSFETs are usually the go-to for this job due to their higher speed and lower power consumption. In summary, both MOSFETs and BJTs are essential components in electronics, each with its own advantages and applications. MOSFETs excel in high-frequency switching applications and are widely used in digital circuits, while BJTs are commonly used in analog circuits and some specific digital applications. And that's a wrap on MOSFETs and BJTs, two integral components in the world of electronics. Remember, every time you use an electronic device, these tiny components are hard at work.